Well, perhaps the skeptic in you are saying, well, how do we know that there are really black holes out there? And basically what we need in order to say that an object is a black hole is to understand its density, to understand how squished or how compact that material is to make up that object. Because we talked about electron degeneracy will support the mass or the density of an object at a certain point, neutron degeneracy at another point, and then beyond neutron degeneracy, the object is a black hole. So we need to know its mass, and there's a few ways we talked about how we determine the mass of stars. We can determine the mass of a black hole the same way by watching it influence the orbital pattern of other objects that we can see. And then the other thing we need to know in order to know how dense it is what's the volume that mass is spread over. And if we have a certain density of an object, then that object has to be a black hole. Well, there are other ways of understanding that we have a black hole up there, or indications, I guess I should say. So, for instance, there is this star in Cygnus, and it's apparently a pair of stars, and one of their stars has an accretion disk. In the center of it is an object that appears to meet the criteria of being a black hole. And so what happens, we looked at other binary stars where the retired star can pull off material from its companion, and so we have this accretion disk, and we talked about X-ray kind of flashes coming from a neutron star that has a binary that's dumping on it. Well, we can also get this sort of radiation coming from the accretion disk if the object is a black hole. And this signal here in Cygnus, called X1, actually is significant. I'm going to take you to one of NASA's websites, and NASA has a satellite up there. I don't know, I guess we can call it a satellite, a spacecraft of sorts, and it is looking for, or ultimately will look for, black holes, and it's called NuSTAR. Have I mentioned lately that NASA has great websites? So this is one of NASA's website talking about this NuSTAR, and it's relatively recent has it been sending back some information, but if you read this article, it actually, one of its points of interest is that star in Cygnus. Okay, so we can't, again, we deduce that is a stellar black hole that's a companion to that star that's getting dumped on and creating these X-ray, giving us these X-ray emissions. Well, gamma ray bursts, we believe, are also caused by the presence of a black hole. And also, I believe it does have to do with in this case, a companion star dumping on a black hole. So gamma ray bursts also come from these stellar black holes. Okay. Gamma ray bursts. Now, if you're keeping track of the energy associated with gamma rays, that can be some very destructive or some intense energies. And so gamma rays, if you're looking at ways to sterilize the Earth, gamma rays would be one way to do it. Okay. So we've also, like the slide says, talking about gamma rays, think that this sort of gamma rays can be associated with supernova type 2 and 1A, and gamma ray bursts can also come if you have two neutron stars that ultimately collide. So very energetic. Here showing you that wispy thing is the host galaxy, and this right here is a star in the wispy galaxy. Okay, you can see it kind of fade away, and it's amazing when galaxies are very far from us, and I think it's interesting. Soon we're going to talk about how we find distances to galaxies, and we look for events, explosive events, such as you're seeing here, to gauge the distance to galaxies.